Today we are going to be talking about theoretical yield and experimental yields, and how with those two pieces of information we can calculate the percent yield. So first, some definitions. The theoretical yield is the amount of product that should be produced in the lab. So if we're talking about an experiment, we can determine the theoretical yield by doing stoichiometry and saying, based on these amounts of our reactants, according to the stoichiometry, this is the amount of product that should be produced in the lab. It's called the theoretical yield because theoretically, this is how much you should make. Okay, again, the theoretical yield is always determined by doing stoichiometry. The actual yield, sometimes referred to as the experimental yield, is the amount of product that you actually produce in the lab. Okay, so this is based on your experimental data. So once you've completed a lab, you use your experimental data in order to say, okay, how much did I actually produce? So again, the actual yield and the experimental yield are sometimes referred to as the same thing, or those terms can be used interchangeably. The percent yield, then, is something that scientists use as a way to compare the actual and theoretical yields. When it comes to percent yield, the higher the percent yield, the better. So when we talk about calculating percent error, like we've done earlier in the year, percent error, you want to have a very low percent error. For percent yield, it's the exact opposite. You want to have a very high percent yield. The higher your percent yield, the closer to the theoretical amount that you should have made. To calculate the percent yield, then, you're going to use the following formula. The percent yield of a substance is going to be equal to the actual yield divided by the theoretical yield. Okay, and then when you get that, you should get a decimal. So to make it a fraction, to make it a percent, we are going to multiply it by 100. So to find the percent yield, we take our actual yield, we divide it by the theoretical yield, multiply it by 100, and that will give us the percent yield for our experiment. Again, the higher the percent yield, the better the experiment went. So we're going to take a look at an example of how we can use experimental data along with stoichiometry to determine our percent yield. So let's say we're given the following equation between the reaction of calcium and oxygen to produce calcium oxide. And we have an 8-gram strip of calcium metal, and we react it with 20 grams of oxygen to produce calcium oxide. Okay, the first thing we have to do before we can calculate the theoretical yield is determine what the limiting reagent of this problem will be. So as a reminder, the limiting reagent is the reagent or that reactant that gets used up first in the reaction. To do that, we are going to start by calculating the moles of each. So we are going to take our 8 grams of calcium, divide it by the molar mass of calcium, which is 40.01, and when we divide that out, we end up with about 0.2 moles of Ca. Okay, we're going to do the same thing for our oxygen, and we're going to take our 20.0 grams of oxygen and divide it by the molar mass of oxygen, which is 32 because it's O2. When I divide that out, I get about 0.625 moles of oxygen. Okay, from here, we have to divide by the coefficients. So the coefficient in front of the calcium is a 2. So if I divide this by 2, I end up with 0.1. Okay, for the oxygen, I'm actually dividing it by 1, the coefficient, which is 1, so I get 0.625. Okay, and now I'm going to compare these numbers, and if I compare 0.1 to 0.625, I know 0.1 is smaller, so this right here is my limiting reagent, which means my starting point for my theoretical yield is going to be the 0.2 moles of calcium. Now that I've determined the limiting reagent, I can go ahead and calculate the theoretical yield. Remember, the theoretical yield is always determined by doing stoichiometry. So I'm going to start with my 0.2 moles of calcium. Remember, I'm trying to find out how much calcium oxide I have. So I'm going to multiply by the ratio, which is 2 calciums to 2 calcium oxides. Okay, cancels, so I end up with 0.2 moles of calcium oxide. And then if I multiply that by the molar mass of calcium oxide, which is 56.01, I end up with a theoretical value of 11.2 grams of CaO. Okay, so again, from my stoichiometry, based on the quantities given, I should theoretically produce 11.2 grams of calcium oxide. Now that I have that information, let's say we actually went through and we performed the experiment, and at the end of our experiment, we ended up with an actual mass of 10.7 grams of calcium oxide. So again, this is based on my experimental value. So this is my actual yield. This is how much I actually produced. To calculate the percent yield, we're going to take our actual value, which was 10.75 grams, and we're going to divide it by our theoretical. Our theoretical, remember, was 11.2, and that 11.2 was determined by doing stoichiometry. So if I divide these two numbers out, okay, I'm going to divide them out and then I'm going to multiply it by 100, I end up with about a 96% yield. Okay, so usually when we talk about percent yield, we're just going to round to the nearest whole percent. So our percent yield ends up being 96%, which again, we want a very high percent yield, so a 96% yield is a very good experiment or very good yield for our experiment.